Yeah. Hello, everybody. Thanks for having me here. My name is Oleks. I'm leading cryptography at Rarimo Protocol. Recently, we started providing access to our Bionetta framework, and I'm gonna to explain what is that. First of all, you need to understand how we came to Bionetta. We started 2 years ago with verifiable credential aggregation. We started to provide aggregation for such protocols like Polygon ID because we had an issue with isolating users' identity on networks where initially issuers created these verifiable credentials. So we have built a messaging protocol for distributing digital identities over all existing networks. Then we came to the idea that if you have some Web1 and Web2 data signed by someone, you can send that to Web3 environment in verifiable manner. And we implemented zero-knowledge passports. So Savio already explained that it's a very easy example. You can prove that some data is included into the passport, but without real and sensitive information. And then we have launched several voting solutions on top of that. To be more accurate, we have launched several solutions for digital protests. So you can vote anonymously without sharing who you are, but at the same time with eligibility criteria. So you can prove that you're Ukrainian, you're adult, and sign the petition using this approach. Then we gave a feedback, and the feedback was how you actually can prove that you're an owner of the passport. Because somebody can steal that, somebody can use that instead of you. I don't know, government can issue millions of passports, and we need to have some protection methods of that. So we started resolving one specific task, and then switch it to the framework. How we have resolved this task? So you cannot prove for 100% accuracy that you are the same person as defined in your passport. But at the same time, you can create a very simple neural network and prove that the distance between vectors derived from your face and from the image in the passport under particular threshold. So the distance is very close. It's not 100 assurance, but at least it increases the cost of the attack a lot. And additionally, you shouldn't share any personal data. So this execution of neural network should happen on your local device with zero knowledge. So you shouldn't dedicate some picture to some trusted server and receive the feedback or attestation. You need to run this model locally. And that's how we came to Bionetta framework, what the Bionetta framework is. First of all, it's a framework for creating provable AI models, some neural networks. And we had made a lot of focus on client-sideness. So you should be able to run different neural networks on your local device and without sharing input data. Some features, architecture in ways should be open and embedded into the circuits. Why you need that? First of all, if you want to launch some on-chain application that needs to consume these proofs, you need to set the statement, what exactly you're going to verify. In this case, your verifier, your application should know that full architecture of the network is used and additional weights. What the weights is some parameters, and you need to set for receiving more accurate solution. So in our case, if you want to prove openly that you're the same person in your passport, this verifier contract should know you're proving this specific statement. Additionally, we have built a RISC-friendly framework. For that, we had one reason. If you have open weights, you can hard code them in R1CS constraints. And it means that you can do all linear operations almost for free. So if you use, for example, some linear regression in your neural network, and you hard-coded these parameters to R1CS, all these layers will be almost zero from proven perspective. Then we applied some special quantization scheme. I'm not gonna talk a lot about that. And we have done some layer-specific optimizations, including right now we are switching to ultra-gross. It's like extended gross 16 with lookup arguments, and it allows you to reduce a lot of constraints from different activation functions. So yeah, like short recap was a like neural network is some difficult black box function. You need to train this neural network with weights. And when you need like to have some prediction, you're putting some input data as a like input function, and you will receive the prediction like relating to the statement you wanna like to prove. And what exactly we can cover with zero knowledge proofs? And there are like two different methods. The first one is used such like frameworks like deep proof, ZKML, etc. They are hiding weights. Just imagine that you have some dedicated server. You want to like prove that the specific neural network worked. At the same time, the architecture of this neural network is open, but you want to hide appropriate weights, because weights is kind of intellectual property, because it's like output of your training process. And for example, just imagine there is some financial organization and you want to like to provide some data, your like credit history, then some AI processes this data and returns the result, but in provable manner. In this case, we have a public input, we have like a public architecture, but weights are hidden. And that's not our case, because as I said, we need to have on-chain verifier that like with hard-coded statement. And in Bionetta, we have public model, public weights, and private input data. As in the case of the passport, your like face and your personal data should be hidden from the verifier. So the verifier also only should be able to verify the statement is valid and you're the same person as the passport. What we did, probably the major part was we developed a custom Rust witness generator because Circum ones couldn't like compile our circuits. So we made like a huge focus on parallelization. Additionally, right now, what you can do, you can use some TensorFlow neural networks, train them, compile to Circum code, and then like prove that as usual one. So using, I don't know, SnarkJS or RapidSnark, any of them. Yeah, probably that's it. Okay, R1CS arithmetization, how I said that you can reduce a lot of constraints, a lot of linear constraints if you hard-coded weights in R1CS. And additionally, we are not limited only by gross 16, so you can use any R1CS friendly prover, for example, Spartan or ultra gross or I don't know, Hyrex, any of them. Because sometimes the selection of appropriate prover also can affect on reducing constraints in some special activation layers. That's like the list of layers we support right now. So you can implement the majority of cases, or the majority of neural networks using Bionetta. Yeah, some benchmarks. We have finished like switching to ultra gross only this week, so that's probably the latest one. The first column, what we have right now, model 1 is like very simple neural network with approximately 80,000 parameters. Model number 6 has around 2 million parameters and a lot of like activation layers. And we can see that for some cases, using gross 16 is much like better than using ultra gross. But for difficult neural network architectures, we received like a dramatic like advantage comparing to our initial version, like comparing to the ZKL framework, ZKML, the proof, etc., etc. Yeah, proven key are relatively small. When we have implemented the first passport, we had approximately 450 megabytes like for proven key. Right now we are launching like the difficult, very difficult neural network having only 150 megabytes for proven key. And yeah, that's doable on the client side. Yeah, verification key are pretty small. And probably the main competitor with our framework is like dproof from Lagrange, because they have very, very efficient prover. But at the same time, the proof size in their case is very large. So it can be, for example, 4 megabytes or 5 megabytes for some cases, and that's not possible like to verify this proof on chain. So that's not compatible with Ethereum right now. In theory, you can convert the verification of GKR with additional, I don't know, gross 16 wrapper or Plonk wrapper, but unfortunately, I couldn't find appropriate benchmarks. So yeah, we have implemented several models. On top of that, for example, the model for liveness, it tries to detect if you are a human. Yeah, you can see that we need to train this model more because sometimes it works better than we expected. We play it with like classifier and additionally implemented a wallet that can be unlocked by any cat in the world. Additionally, you can build a model that recognizes a specific object, a specific physical object, extracts the unique distinguished points from this object, and in this case, you can recover your account only with the knowledge of this specific object. And it could be better than seed phrases. Yeah, several resources. We additionally like implemented a demo of like airdrop for all humans. It like works in browser. Right now you can play with MNIST, so that's like a test vector for hand digit numbers, and you can just draw the number and prove like this execution trace. What is next? The first of all, finishing ultra-gross, because we didn't test that yet for very, very large and difficult models. Next one, switching to Noir, only like for improving development experience. Still, it will not be friendly with Plonk, but we are finishing a translator from ASIR to R1CS. So you will be able to like write code in Noir and then compile that to R1CS and prove with Bionetta. Then we are finishing front-end and mobile SDK, so yeah, you can integrate this model in your application. Different libraries with models, mobile acceleration. Yeah, recently we started working with Ingonium, and they provided like a very efficient prover for gross 16. Right now we are working on like integrating ultra-gross with their hardware acceleration. Not hardware, software acceleration. And the next one, yeah, probably we started with TensorFlow, but definitely the majority of AI developers use PyTorch right now, so we need to support that. I don't know when, but that's our next step. Yeah, that's it. Feel free to reach me if you have any questions. I will try to answer.
Thank you for the talk. Curious, what was the hardest part throughout the, I guess, entire development or the exploration that you went through, if you have to pick one?
Probably the hardest part and probably additional disadvantage is that's the time you need right now to generate a witness and compile initial model. One more disadvantage is, as we working with ultra-gross and gross 16 right now, we need to have a per circuit setup for each model. And yeah, additional setup, additional trusted quorum. So there are like more secure problems with security that it could be with the Plonk, for example, or with Starks. But anyway, yeah, probably this one are major ones. Good. Yeah, thank you again.